everyone, this is Songwee and today I'm here with a Java lesson. So today we're going to be learning about the basics. So first off, what is Java? Well, Java is an object-oriented programming language, and essentially an object-oriented programming language is one where real-world objects are modeled by software objects. So for example, you can have an object that's like a dog or a cat or a bird. So today what we're going to be covering is we're going to be learning about classes versus objects, primitive types versus object types, methods, and finally types of errors. So first off, classes versus objects. Classes are blueprints for an object, and objects are when you create an instance of the class. So to give you an example, let's say there's a class called an animal class. Then from that animal class, you can make objects such as dogs or cats or other kinds of animals that would fit inside an animal class. So what the class does, it provides a blueprint for those dogs and cat objects to use. The convention for naming classes is upper camel case. So what this means is that you capitalize the first letter of every single word in the class name. And for objects, when you create an instance of the class, that's called instantiation, and the convention for that is lower camel case. So you lowercase the first letter of the entire name, but you capitalize the first letter of all the words after it. And a little more about objects. So objects are essentially made of two main parts. It has what it remembers and what it does. And it can get these things from the class that you're creating the object from. So what the object remembers is called instance variables. And so, for example, if we have an animal, this could include things like number of legs, food, and things like that. And what it does would be methods, which I'll get to a little later on. So if we have an animal class and we make a dog object, then the kind of methods could be speak or eat or move and kind of what the object will do. So how do we make an object and how do we make a class? Let's say we already have a class called animal. Create an instance of that class. If we have a class called animal, we would do new animal. And then since it is an animal, we have to do animal and we give it a name. So you can name this anything you want. I can name it like Fred, and this means you've created a new instance of the class. Alright, now let's move on to primitive versus object types. So primitives are things like integers, Boolean, double, float, and char. There are some others as well, but the main ones we'll be using are integer, Boolean, and double. And objects are, like I explained before, instances of a class, and one of the most common ones we'll be using is string, which is letters and words. So for example, your name would be a string, cat, apple, things like that are strings. So a little more on primitives. So the three main primitives we'll mainly be using are integer, Boolean, and double. So int, in Java, you write it as int, int, and in real life, those are all the integers. So there'll be things like -1, 0, 3, 200, all of those. Boolean is true and false. When you make it in Java, you do Boolean is true equal to true, or Boolean is false equal to false, things like that. And double are just real numbers. So any real number can be represented as a double. So some examples of this would be 3.14, 0.0, minus 85.0. And how do we use these primitives? Well, we use things called variables. So variable is essentially named storage in memory. So all computers have memory, and inside the memory space, variables and things are stored accordingly. Variables always have a type. For example, like primitive types, they always have a name. You have to give a name to the variable. It has a value, which means you assign something into that variable, and it has a scope, which is where it can be used. So when we get to methods a little later on in the video, there are certain scopes of different variables and where and when they can be used. So when you make a variable, there are essentially three parts. There's the declaration, which is when you give it the type and the name. There's the assignment, which is when you give the variable a value, and there's the initialization, which is the first assignment. So the very first time you assign a value to the variable, that's the initialization. Any time after, when you re-give it a different value, that's just another assignment. So if we look here at this example, int number equal 23, then the int number would be the declaration. Int is the type, so it's an integer, and the name of the variable is number. The assignment would be number equal to 23, so the 23 part is where we're giving the number a value, and this is the initialization because it's the very first assignment. You can only initialize a variable once, so you can only do int number equals 23 once. You can't do int number equals 50 later on in the code. You would have to do just number equals 50 because you've already declared it. You can only declare it once. And after that, you're just reassigning the variable a different value. But what if we want to change what the variable is? Well, then we can do something called casting. So as I showed you before, the int number equal to 23, that's just, it's an integer, and we're saying it's an integer, so everything is fine. If we go to a double, which is again any real number, but it's a decimal, if we have double x is equal to 17, then you'll notice that 17 doesn't have a decimal point. But Java automatically converts integers into doubles because we're not losing any information. 17 will be stored into the double as 17.0, but since we're not losing any information, Java automatically does it. And this is called implicit casting, also known as widening. But what if we do the opposite? What if we do int j is equal to 32.5? Then 32.5 is a double, and we're trying to say it's an integer, but it's not. And Java doesn't allow this, so it'll do a compiler error, because we'll be losing information if we say it's an integer. We'll be losing the 0.5 because 32.5 isn't an integer. But then what if we do 32.0? We're not losing any information then, right? Well, actually, Java still classifies it as losing information because the 0.0 still technically is some information, so we can't do int j equals 32.0 either. So int j equals some double always gives a compiler error. But what if you really want a double to become an integer? Then you can cast it. This is known as explicit casting or narrowing. So to do this, you would do int j equal to parentheses int, and then in parentheses the number that you want the double that you want to cast to an integer. So for example, if I have int j is equal to int 135.7, that becomes 135. Java truncates, which means it doesn't round up, it just cuts off the end of the number. So everything basically just rounds down. So 135.5 would become 135, 135.1 becomes 135, 135.9 becomes 135 if you explicitly cast it to an integer. So now that we've talked about casting, when we do mathematical expressions, Java still uses the order of operations. So these are the order of operations that you've probably learned already just at school or just in math class. PEMDAS. So the order of operations is parentheses first, exponent second, multiplication division on the same level, it just whichever comes first is executed first, and addition and subtraction are on the same level, whichever comes first order-wise is executed first. So now let's talk about integer division. So integer division in Java is a little different from normal division at school. So if you were to do 7 divided by 0 at school, that would be 1.75. But in Java, since 7 is an integer and 4 is an integer, that 7 divided by 4 just becomes 1, because it would be 1.75, but if you assign it to an integer, then the last part that isn't an integer gets truncated, so it just becomes 1. If you have double 1 over 4, then the double casting applies to the first part of the number. Notice that there aren't parentheses around the 1 over 4, which means it gets applied to the 1. So then the 1 becomes a double, and you have 1.0 divided by 4, which then becomes 0.25. Now if we look at the example below that, which is double and then 1 over 4 in parentheses, this returns 0, because 1 over 4 is 0.25, but since it's integer division, it's actually stored in Java as 0, and if you cast 0 as a double, that just becomes 0.0. So the answer would be 0. Now what we've seen here is an example of something called promotion. So promotion is basically if you divide an integer by a double, or you have some double multiplied by an integer divided by an integer, then it promotes the other number to a double. So if you just have 7 divided by 2, that'll be 3. Since 7 divided by 2 is 3.5, it truncates the 0.5, so it's just 3. But if you have 7 divided by 2.0, then Java promotes the 7 at the start to 7.0, so it becomes 7.0 divided by 2.0, which is 3.5. If you have 7 divided by 2 times 1.0, then it, according to the order of operations, it does a 7 divided by 2 first, which is 3, and then it multiplies the 3 by 1.0, so it promotes the 3 to 3.0, and then 3.0 times 1.0 is 3.0. So now that we've done integers, let's talk a little bit about Boolean operators. So the 3 Boolean main operators that we have are the exclamation point, 2 ampersands, and then like the pipeline symbol. So the exclamation point is a not. So if you have that in front of something, that means not. So for example, we could do is true not equal to false, and that would just mean that it's not equal to. So you can use the not in front of a Boolean method, or when you call a Boolean method, or in front of an equal sign, and it just means not. The double ampersands is and. So in Java, an and isn't like the word and or just 1 ampersand, it's 2 ampersand, and it means and. And then the 2 long pipelines, which is normally right under near your backspace sign on your keyboard, is the or symbol. And the order of operations that Java regards these 3 in is the exclamation point, or the not, also known as bang, comes first, and then the and then the or. So if you don't have the not and or in its respective parentheses, then it'll evaluate the expression in that order of not and then or. Alright, now let's go to methods. So here we're going to be talking about return types, parameters, arguments, pre and post conditions, and scope, which is something I mentioned a little bit earlier when I was talking about variables. So the most common method you'll see is the main method. So this is written like this. And here is the code that will kind of execute. So if you make other methods, then you call them in the main method so that it'll execute the methods. So, for example, we're going to make a method, and we're going to make this static because our main method is static. And then this is where you put the return type. So the return type of the method is going to be an integer. You can make it a double, but I'm going to make it an integer. And this is where you put the name. So this is going to be called add. And then this is a parameter. So integer x is a parameter, and that's what we're going to be getting from whoever wants to use the method. And we're going to return a value of x plus 1. So x plus 1 is an integer, and the return type is an integer, so everything works fine. And then we can call the method up here, and we'll do this. So then this will return a value of 6. But you'll notice that we don't have the value stored anywhere, but if we want to store it, we can do int. We can make a new variable, so we declare it, and then we assign it to this value, and this is the initialization since it's the first time we're doing it. And so now changed has the value of 6. But what happens when we put this 5 value? What this does is it goes into here, and we're not changing the value of this 5 directly per se. It kind of makes a copy of the 5 as an integer x, and it returns that changed copy. So for example, if instead of 5 we had int number and then this were 5, and we changed number, then number is still 5. We don't change number directly. Changed is now 6, but number still remains 5. So you'll see here that if we print out the values of changed and 5, then number prints out 5 and changed prints out 6. So methods kind of make a copy of it, and this is sort of what scope is. So we have the integer x here, but if we were to call integer x above the method where it's not in scope, it wouldn't work. So if we do int number is equal to x, or number, I guess number 2 is equal to x, then it doesn't work because there's no x and this is out of scope. And a good practice for methods is preconditions and postconditions. So precondition is something that must be true in order for the method to run properly, and a postcondition is what will be true after the method has run, provided that the precondition has been met. So for example, then you'll see here it automatically has like the parameter x and the return, and you can describe what those are, but there are also things called preconditions and postconditions. So a precondition, there's no precondition, so we can put none, and postcondition is like number returns a number 1 larger. And preconditions and postconditions are especially helpful when you're going to look back at your code after some time, and it helps you understand your code, and it also helps with working together with other people so that they can just call the method and they know what should happen and what they need to meet in order for the method to work properly. Finally, let's look at types of errors. So there are 4 errors we're going to be looking at. There are more specific and nuanced, but these are the main kind of overarching ones. So there are lexical errors, syntax errors, runtime errors, and errors of intent. So lexical errors are things like spelling errors, just small, mainly spelling mistakes. Syntax errors are when you get the syntax for something wrong. So for example, if you don't have a semicolon at the end of every statement, which in Java you do need a semicolon. Or if, for example, you're missing a parentheses, or if you're missing a bracket, things like that. A runtime error is when something doesn't run properly and so it just doesn't execute. So this is also known as an execution error, and your program will crash. And finally, which is probably the worst kind of error, is an error of intent. So this is when the code, it all runs properly or it all compiles properly, there are no syntax or lexical errors, but it doesn't do what it's supposed to, so it gives the wrong output. And Java is a slightly more finicky language than, say, JavaScript, and part of the reason for this is because you prefer lexical and syntax errors to runtime errors and errors of intent, because they're easier to, most of the time they're easier to fix, and you catch them before the program actually runs. So if you're doing this for a client, then you'll catch the error before you send it to the client. But if you have an error of intent, then it won't work properly once it goes to the client, which is a lot worse than the code not working when you're just fixing on it so that you can fix lexical or syntax errors. So that was a short lesson on the very basics of what Java is, and next time we'll be doing some more things with mathematical operations and loops. So I'll see you next time, and thank you. Bye.